Transistors are the building blocks of modern electronics. Whether used for switching, amplification, or power control, they are crucial in everything from tiny microprocessors to large power circuits. Understanding their operation helps in designing and troubleshooting electronic circuits. Transistors are one of the most fundamental components of modern electronics. They function as electronic switches and amplifiers, enabling the operation of everything from microprocessors to power supplies. Let's explore their structure, types, working principles, applications, and real-world significance in greater detail. 1. What is a transistor? A transistor is a three-terminal semiconductor device used to control the flow of electrical current. It functions primarily as a switch or amplifier, making it a crucial component in digital and analog circuits. Basic components of a transistor. A transistor consists of three key regions. Emitter, be heavily doped to release charge carriers, electrons, or holes. Base, be thin and lightly doped. It acts as a gate to control the flow of carriers. Collector, see moderately doped and larger in size to collect charge carriers. 2. Types of transistors. There are two main classifications of transistors based on their operating principles. A. Bipolar junction transistors, BJT. BJTs work by allowing a small input current to control a larger output current. They are bipolar because both electrons and holes participate in conduction. Types of BJTs. NPN transistor. Current flows from the collector to the emitter when a small current is applied to the base. PNP transistor. Current flows from the emitter to the collector when a small current is drawn from the base. Working of BJT. A BJT operates in three modes. Cutoff mode, OFF state. No current flows from the collector to the emitter. Active mode, amplification. A small base current controls a larger collector-emitter current. Saturation mode, on state. The transistor acts as a closed switch, allowing maximum current flow. B. Field effect transistors, FET. FETs are voltage-controlled devices where a small input voltage at the gate controls a larger current between the drain and source terminals. Unlike BJTs, FETs are unipolar, meaning they use either electrons, N-channel, or holes, P-channel, for conduction. Types of FETs. Junction field effect transistor, JFET, controlled by the depletion region in a semiconductor junction. Metal oxide semiconductor field effect transistor, MOSFET, the most widely used transistor found in microprocessors and power circuits. MOSFET types. Enhancement mode, normally OFF, turns on when a voltage is applied to the gate. Depletion mode, normally on, turns off when a voltage is applied to the gate. 3. Working principle of a transistor. How a transistor switches. OFF state. Cutoff mode, no current flows because the controlling voltage is too low. On state, saturation mode, a sufficient input signal allows full current flow through the transistor. Amplification, active mode, a small signal at the base, BJT, or gate, FET, modulates a larger current through the transistor. This switching mechanism is the basis of digital circuits, enabling binary logic, zeros and ones. 4. Key applications of transistors. Transistors are found in virtually all modern electronic devices. Here are some of their most common uses. A. Switching applications. Logic gates. Transistors are the building blocks of digital circuits like microprocessors. Relay replacement. Faster and more efficient than mechanical relays. LED control. Transistors switch LEDs on and off efficiently. B. Signal amplification. Audio amplifiers, used in sound systems and mobile phones. RF amplifiers, used in radio transmitters and receivers. Sensor signal boosting. Weak sensor signals are amplified for processing. C. Voltage regulation. Voltage stabilization, used in power supplies to provide constant voltage. DC-DC converters, convert one DC voltage level to another, e.g., in phone chargers. D. Oscillators and signal generation. Clock circuits. Transistors generate timing pulses in digital devices. Radio frequency oscillators, used in communication systems. E. Power electronics. Motor control. Transistors regulate the speed and direction of motors. Inverters, used in power systems and solar energy conversion. 5. Advantages and limitations of transistors. Advantages. Heavy checkmark compact size, smaller and more efficient than vacuum tubes. Heavy checkmark low power consumption, ideal for battery-operated devices. Heavy checkmark fast switching speed, essential for modern computing. Heavy checkmark long lifespan and reliability. Disadvantages. Heavy multiplication X heat generation, requires cooling in high-power applications. Heavy multiplication X static sensitivity. MOSFETs can be damaged by electrostatic discharge. Heavy multiplication X complexity in circuits, requires additional components for stabilization. 6. Transistor in modern technology. Transistors are the foundation of integrated circuits, ICs, which power modern technology. Microprocessors, billions of transistors in CPUs enable fast computing. Memory chips, transistors store data in RAM and flash memory. AI and IoT, transistors enable low-power processing in smart devices. Conclusion. Transistors are the backbone of electronics, enabling everything from basic circuits to advanced AI computing. Understanding their working principles and applications helps in designing, troubleshooting, and improving electronic devices.